Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, now we are going to do a new topic which is isoelectronic species, and this is related to number of electrons present in an atom or an ion. So let us talk about it. So now we are going to talk about isoelectronic species. So what are isoelectronic species? Let us talk about that. So the isoelectronic species, that can be an atom also or that can be an ion also, are those which have same number of electrons. So those two or more than two species which will have same number of electrons will be known as the isoelectronic species for each other. So for that we have an example, as you could see, that is Na plus ions, Mg2 plus ion and Al3 plus ion. So let us check how these three are said to be isoelectronic species of each other. So let us talk about that. Talking about the first one, that is the sodium Na plus ion. So for that we have if we are talking about a parent atom like sodium atom, so sodium atom, since we know that the atomic number of sodium, basically it has been represented by Z, so therefore the atomic number of sodium is equals to 11. So this atomic number which is equals to 11, it means that the number of electron, or as well as we could say that the number of proton is equals to 11. But what happens when its electron it loses? For example, if Na plus has lost one electron, so therefore it can be written as the sodium. Suppose if it has lost one electron, so therefore it could be written as Na plus. So but if we count the number of protons in it, so the number of protons in this case will be 11 itself, because this number of electrons will be nothing but the atomic number of the sodium, which is nothing but 11. But talking about the electrons, so the number of electron will now be, as you could see, there is a positive charge here, means one electron has been lost. So out of initially there were 11 electrons as well as 11 protons. So now as you could see that because of Na plus, or when it is in a form of a cation, so one electron has been removed. So therefore what will happen, that out of 11 electrons which was earlier present in a sodium atom, so because one electron has been lost, so therefore 11 minus 1, this minus 1 because the electron has been lost, one electron has been lost, so therefore now the number of electron is now 10. So therefore the number of electron in sodium plus ion, that is Na plus ion, is now 10. Talking about the, I will mark this one so that this would be we'll notice this thing. And also we have Mg2 plus ions. So for that we know that magnesium has an atomic number of 12. So therefore the atomic number which is represented by Z, it is nothing but the number of protons, which is 11. But when it is in atomic form, when the magnesium is in atomic form, so what happens, the number of electron will also be the same. That is, sorry, in this case it is 12. In this case it is 12. Continuation. हेलो नागेश सर, एक्चुअली यहाँ पे Mg12 लिख रहा था लेकिन यहाँ पे मैंने 11 लिख दिया था, तो यहाँ पे थोड़ा सा गलती हो गया है. तो मैं क्या करता हूँ, मैं ये जब मैंने एंड किया था ये वाला पेपर, ये जब मैंने एंड किया था उसके बाद फिर मैं शुरू करूँगा, तो इसको मैं हटा दे रहा हूँ एंड उसके बदले में मैं न्यू तरीके से शुरुआत करूँगा. Continuation. So the next species that we have, it is Mg2 plus ion. But before understanding what will be the number of electrons in the Mg2 plus ion, so let us talk about what will be the number of electron in magnesium, which is present in an atomic form. So magnesium has an atomic number of 12. So therefore the atomic number, which is nothing but the number of protons, it represents the number of protons. So the number of protons in magnesium in this case is, as we could see, it is 12. In an atomic form, if the number of electron is 12, so the number of electron will also be the 12, because the number of electron and as well as the number of proton, the both are same when we are talking about a atom. So now in this case also the number of proton, which is 12, and now the number of electron will be also 12. But what happens when we are talking about Mg2 plus, that is Mg2 plus ion? So in this case what happens is the atomic number of magnesium, that will be 12 itself. So therefore the Z, that is the number of proton, in this case would be 12 itself. But what happens when we count the number of electron? So the number of electron in this case will not be 12, because as you could see that there is 2 plus charge here. So this 2 plus charge means the 2 electrons are being lost from the magnesium, and that's the reason the 2 positive charge has came on the, or we represented by 2 positive charge on the atom, which is known as a cation. So in this case basically 2 plus charge has been acquired on the atom, so that means 2 electrons have been lost. So out of 12 basically 2 electrons are being lost, so therefore it makes a total number of electron in Mg2 plus to be 10. So this is how we represent. That means that Na plus and Mg2 plus, they both are isoelectronic species because they have same number of electrons. But talking about the last one that we had an example of aluminum 3 plus. So before talking about aluminum 3 plus, let us talk about aluminum first itself when it comes to the atomic form. So when we are talking about aluminum as an atom, so therefore the atomic number is basically 13. So atomic number, that is 13, that means Z is equals to number of proton, I will write it as P, will be 13, as well as the number of electron will also be 13 itself when we are talking about aluminum which is present as an atom. So when we are talking about now as an Al3 plus ion, so as you could see this is Al3 plus ion, and in Al3 plus ion what happens is the number of proton will remain the same, that is when we are talking about the atomic number, so the number of proton will be the same, that is 13, but the number of electron, as you could see here, will not be 13 because 3 electrons have been lost, and that's the reason 3 plus charge has been acquired on the aluminum, which makes the aluminum 3 plus to be an ion. So now the number of electron, it was initially 13, but now 3 electrons has been lost, so therefore 13 minus 3, it becomes 10. So the number of electron is now 10. So in all the species that you have that we have got to know, that is whether it might be aluminum 3 plus, or might be Mg2 plus, or might be Na plus, all had the same number of electron, that is 10. So that's the reason they make isoelectronic with each, they are isoelectronic with each other, and hence this kind of species which have same number of electrons are known as isoelectronic species. But the number of electrons will be the same, but the number of protons will be different when we compare this two. So similar to that, we are going to check whether what would be the atomic size for that, and what would be the nuclear charge, and etc. that would affect this isoelectronic species. So let us talk about that also. So we have clearly understood that what is isoelectronic species, and now what we are going to study is, we are going to study that what would be the effect on the atomic radius or the nuclear charge when it comes to the isoelectronic species. So for talking that, we have an example, as you could see here. In this case, what we have to do is we have to arrange the following species in decreasing order of radii or size, that is atomic size. So before that, let me tell you that first of all, we are going to check whether this all are isoelectronic species or not. So recently only we have determined that this all are isoelectronic species, but let us check for the Si4 plus, that is silicon 4 plus ion. So in this case, the aluminum 3 plus ions, which had an number of electron which was found to be, that is, if I'll write here, so the number of electron which was found to be for aluminum, it was 10, because aluminum has an atomic number of 10, atomic number of 13, and if 3 electrons gets loosed, so the number of electrons that has been left in the Al3 plus ions is nothing but the 10 itself. And talking about the magnesium has an atomic number of 12, and if 2 electrons gets lost, then only it will convert into Mg atom into Mg2 plus ion. So in this case, the number of electrons that would be present, it is 10. And talking about the silicon 4 plus ion, so silicon has an atomic number of 14, which makes the silicon to have 14 protons as well as 14 electrons when it comes to the atomic state. But when it comes to the ionic form, that is when we are talking about Si4 plus ion, that means 4 electrons are being lost from the total 14 number of electrons, which will make the total number of electrons after the 4 electrons are being lost, it will make the number of electrons to be 10. And we know that for sodium has an electronic number of electrons as 11 when it comes to atomic state, but when it comes to an ionic state like Na plus ion, that means 1 electrons are being lost, and because of which the total number of electrons is now basically 10. So this all are basically isoelectronic species, as we could see. But now the main challenge is we have to compare that which one of this would have the maximum size, or which one of this would have the lowest size. So first of all, let us arrange this by showing this thing that which one would have a maximum nuclear charge, because nuclear charge is the factor that would affect on the atomic size. And in the previous lecture we have did that the nuclear charge was one of the factors that was affecting the atomic size or the ionic size of a particular species. So similarly, that what we are going to do is we are going to check whether in this case which one would have the maximum nuclear charge. So for that, we have basically Si4 plus ions as well as Al3 plus ion. So in this case, what we could see as if the number of electrons are being lost so as to make the isoelectronic species, which makes a total number of 10 number of electrons that are being present in the ions. So in this case, what happens is if the number of electrons are being lost, so that means the positive charge will increase. So for example, in this case, that is in Al3 plus and Mg2 plus, Si4 plus and Na plus. In this case, let us compare that what would be the atomic size when it comes to the atom. So talking about the first one, that is Si14, when it is present in an atomic form. So how can we do this thing? We can do this thing by writing the that is F-Boss principle that we know. So that for I could write it as 1s2, 2s2, 2p6, 3s2 and 3p4. So this indicates what? This indicates that the total number of shells in this case is basically 3. So therefore the first one will have the nucleus itself, and this nucleus will be surrounded by the first shell, and in this case the first shell will contains 2 electrons. So this is the first shell which contains 2 electrons, and now the second shell will totally consist of basically 8 electrons. So I will write it here itself, 8 electrons, and the third shell will have a total of basically 6 electrons. But in this case, what we could see that when we are talking about Si4 plus, that is Si4 plus, that means the 4 electrons are being lost. So basically we could say that the 4 electrons out of 6 electrons, as you could see here, out of 6 electrons, 4 electrons are being lost. That means the 4 positive charge will acquire on the atom. So in this case, suppose 4 positive charge will acquire on the atom. So this will lead to what? Because electrons are being lost from the atom, and what will happen, because when we are talking about a nuclear charge is nothing but the force of attraction between the nucleus and the outermost electron. So in this case, what happens is because the 4 electrons are being lost, and moreover we could see that the positive charge is also being in this case is more. So what will happen? The atomic size will go on reducing, and moreover what we could say that the nuclear charge will go on increasing in this case, because the electrons are being lost, and the loosely bonded electrons they are lost first. So therefore the electrons that are remain in this shell will be very much closer, or will have the more effect of attraction with the nucleus, and that's the reason the Si4 plus will have more nuclear charge, and compared to that of the aluminum, and then for the magnesium, and then for the sodium. So therefore in this case, by taking the example of the silicon, we have got to know that the nuclear charge will be maximum in case of the silicon 4 plus ion. So therefore the nuclear charge will be in the order of, as we could see, that is Si4 plus ion will have the maximum nuclear charge, while compared to that of the Al3 plus ion, compared to that of the Mg plus 2 ion, and compared to that of the Na plus ion. So this is the nuclear charge when we have made an arrangement in this format. So, but when we are talking about what would be the atomic size or what would be the ionic size, in this case we will talk about ionic size, because this are all are ions, these are not atoms. So we are now going to talk about what would be the effect and what would be the increasing order or the decreasing order of the ionic size. So therefore when we comes to ionic size, we know that the atomic size as well as the ionic size, they both are inversely proportional to the nuclear charge. So if the nuclear charge is more, then what happens, the atomic size gets reduced, so atomic size will be less. And if the nuclear charge is less, then it is but obvious that the atomic size will or ionic size will be more, or it will go on increasing. So similar to that, as we could see that the nuclear charge is maximum at Si4 plus. So therefore this will make the Si4 plus ions to have the least atomic size compared to that of the other one. So therefore we could say that the Si4 plus ion will have lesser ionic size compared to that of the aluminum 3 plus, compared to that of the Mg2 plus, and compared to that of the Na plus. So this makes even all are basically isoelectronic, but they will have effect on the atomic size, or we could say as ionic size. So they have an effect on this thing, and it depends on the nuclear charge as well as it depends on the number of positive ions. When we are talking about a cation, it depends on the number of positive ions, and because of which the number of size will get reduced or will get increased. So it will depend on that also. So this is what the nuclear charge as well as the isoelectronic species are basically related to each other. So for that we have another question also, so as to make us understand that to go in a deep concept that what we are going to talk about when it comes to isoelectronic species as well as the atomic size. So for that we have this, that is these are the two questions that we have to do. That is, we have to decide that which of the following species will have the largest and the smallest size. So there are two questions in this case. That is, one is for magnesium. These are the groups of species that they have provided to us. That is magnesium, Mg2 plus, aluminum, and Al3 plus. So this is the first question, and in this case we have to determine that which one would have the highest atomic size or ionic size, and which one would have the smallest ionic or atomic size. So therefore let us do that. That is for the first one, that is we have the first one, that is magnesium, then Mg2 plus ion, and after that we have aluminum, and then Al3 plus ion. So first of all, let us arrange with the atomic size that we have got to know recently, that when we have did for nuclear charge, as well as on that basis we have made a decision that which one would have the highest or which one would have the lowest atomic size. So in this case, let us compare the first thing, that is let us compare the atoms first, and then we'll compare it with the ion. So in this case, the first thing is, if I compare magnesium and aluminum, so magnesium has an atomic number of 12, while that of the aluminum will have the atomic number of 13. And moreover, what we could see that as we move from left to right along the period, so the first thing is magnesium will appear, and after that aluminum will appear. So whenever we move from left to right, what happens is, because of the atomic number increases, as we could see that the atomic number is increasing in this case, and moreover we could see that if the atomic number increases and the number of shell will remain the same, and the electrons are being added. So for example, if I am talking about the magnesium, so it will have the 12, it will have 12 electrons, while that of the aluminum will have 13 electrons. So this will make the number of electrons to be more when it comes to left to right, or when we cross across the period. But the nuclear charge will be increased. So as the atomic number increases along the period, nuclear charge increases, which makes the decrease in the atomic size. So what will happen in this case actually, when we move from left to right, in this case the magnesium will have more nuclear charge, aluminum will have more nuclear charge than that of the magnesium, but it will result in a conclusion that Mg12 plus is having more atomic size than compared to that of the aluminum 3 plus. So in this case we have got a competition that we have decided that Mg12 plus is having a positive charge, is having a maximum size compared to. So now we have compared the magnesium atom as well as the aluminum atom, and now what we are going to compare, we are going to compare with the Mg2 plus ions and Al3 plus ion. So therefore we have Mg2 plus ion and Al3 plus ion with us, and in this case we have to compare that which one would have the more atomic size, or which in this case, but these are the ions, so therefore we are going to talk about ionic size. So in this case basically the Mg2 plus is the one which has 2 plus charge, or we could say that the number of electrons that has been left in this case is 10. And talking about the aluminum 3 plus ion, again the aluminum 3 plus ion will have the number of electrons that will be left in the aluminum 3 plus ion will be 10 itself. So now the main thing is we have to compare that which one will have the more nuclear charge. As we could see that the aluminum 3 plus ions and this Mg2 plus ion, in this case the higher number of positive charge is in the case of aluminum 3 plus ion. That means 3 electrons are being lost from that atom, which will result in the more nuclear charge in case of aluminum 3 plus ion. That means the nucleus, the attraction between the nucleus and the outermost electron when it comes to the aluminum 3 plus ion will be more in that case of compared to that of the Mg2 plus ion. So now in this case the nuclear charge is more in case of Al3 plus, but if the nuclear charge is more in case of Al3 plus ion, that means the atomic size will be, the ionic size will be less. So now Mg2 plus ions will have basically more, the atomic size will be more in this case of Mg2 plus ion. So therefore in this case what we have got to know, we have got to know that Mg2 plus ion has more size than compared to that of Al3 plus ion. But the question that was been asked, that we have to decide that which one will have the largest and which one will have the smallest size. So we could declare in this thing that as we have compared that always an atom is having a larger size than compared to its cation. So in case Mg2 plus will always have an bigger size than that of the Mg2 plus ion, while that of the aluminum 3 plus ion, aluminum 13, that is when it comes to an atomic state. So aluminum when it comes to atom will have more size compared to that of the Al3 plus ion. So in this comparison what we had a question that in this case which one would have the largest size. So therefore the largest size that we could say that the largest size is for the magnesium atom, while in case of the smallest one, so the smallest size in this case is basically Al3 plus ion, because it has the maximum nuclear charge compared to the other one, and that results in to give a conclusion that Al3 plus ion is the one which have the smallest size. So therefore Al3 plus is the one which will have smaller size. So this is the theory that we have did earlier also. So based on this theory we could easily predict that what would be the size when it comes to a comparison that we could do on the basis of an isoelectronic species. So this is how we can do this thing. So now let us talk about the second question that we had. We had a second question in which basically Mg, Mg2 plus, Fe and Fe3 plus were present, and in this case we have to compare that which one would have the more size compared to that of the other one. So therefore the first thing is, the question that is given to us is it consists of Mg, again Mg2 plus, and comes Fe, and then it comes Fe3 plus. So in this case what happens is we have to compare what would be the atomic size of magnesium and Fe when they both are present in an atomic form. So magnesium is the one which consists of basically 12 electrons, while that of the Fe which consists of basically 26 electrons. So this results in what? Because as we know that is as we move from left to right across the period, the atomic size goes on decreasing, but the atomic number, it goes on increasing by a unit. So when it comes to the magnesium is the one which is present in the S block, while the iron which is present in the D block. So by comparing this also, the atomic size that was being known to us, it was found that the magnesium will have more atomic size than compared to that of the iron, that is Fe. So in this case, Mg will have more atomic size than compared to Fe. So now when it comes to the Mg2 plus ion, so let us talk about the Mg2 plus ion as well as the Fe3 plus ion. So now when it comes to Fe3 plus ion and Mg2 plus ion, so in this case, as we could see that the total number of positive charge is more present on the Fe3 plus, and while case of in Mg2 plus, it is only 2 charge or 2 positive charge, as we could see. So in this case, what happens is this Fe3 plus, which will have more positive charge, so that will have an resultant net nuclear charge will be more in this case of the Fe3 plus, while in this case it would be less. So that will make, and moreover it is of a D block element, and moreover this thing will have less shielding effect, and hence the size of the Mg3 plus will be less compared to that of the Mg2 plus ion. So in this case, basically the one which has the largest size is nothing but the Mg, while the one which has the lowest or the smallest size is nothing but Fe3 plus. So this is how we have did. So thank you friends for watching this video. I hope you have understood that what is isoelectronic species and how does it affect the atomic size when we compare this thing. So thank you friends for watching this video. Share this video with your friends, and just don't forget to subscribe to Ekeeda channel. Thank you so much.